Right, so this is the Specimen paper 2020. So this is when the specification changes. They're given a practice paper to look at the new specification. It's the non-calculator paper. So if we look at the first question, this is something that you could get in a normal GCSE paper. So we have got simplifying indices. So I'm just going to simplify the indices. So this is the same as y to the 6 multiplied by y to the 1 divided by y to the m. So I know that if I'm multiplying, I'm going to add the powers together. So I'll give me y to the 7 on the numerator and y to the m on the denominator. I also know when I'm dividing, I'm going to subtract the powers. So I've got y to the 7 take away m. If I compare that to the other side, I know that that has to equal 4. So therefore 7 minus m has got to equal 4. So therefore it's going to be 3. If we look at part B, it's quite similar in nature. So we're adding powers together. So I know that I'm going to do a to the n plus 5. And that has got to equal a to the 5. So therefore n has got to be 0. If we look at part C, I can multiply these indices together. So that would give me c to the 5p is equal to c to the 12. So we can equate the indices. So 5p has to equal 12. So p is 12/5. Question 2 is solving a relatively simple equation. So if I've got a cube root on this side, think about the inverse operation would be to cube it. So I'm going to cube both sides. Okay, and 2 cubed is 8. And now I have got quite a simple equation to solve. So if I add 13 to both sides, I've now got 21. And if I divide by 7, I get x equals 3. Question 3 is an identity. So the idea behind identity is that both sides are equivalent for all values of x. So the idea is you're going to simplify one side and then equate your coefficients on both sides. So if I expand the brackets for the first set of brackets, I've got not 3, but 6ax take away 3a. If I then do my second set of brackets, I'll get 4ax add 20. And that's identical to 60x plus b. Okay, so I'm just going to organise this side a bit more clearly. So if I look at my x terms, I've got 2 terms that have got x in them. So I've got 6a and 4a, lots of x. So in other words, I've got 10a x. Okay, and then anything that hasn't got an x in, I'll do this in a different colour to show you. So these ones are what haven't got an x in them. So if I combine those together, obviously there's not much I can do with that. So my constant would just be 20 minus 3a. So we're going to compare both sides. So on one side, my coefficient of x is 10a. On the other side, it's 60. So 10a equals 60. A has got to be 6. If I do the same for my constant, so on my constant, I've got 20 minus 3a and b. So 20 minus 3a has got to equal b. And we've already worked out that a was 6. So I'm doing 20 take away 3 lots of A, which is 18. So B ends up as being 2. For number 4, we've got a straight line, and AB to BC is in the ratio of 5 parts to 2 parts. And we're trying to work out the coordinates of C. So if you think about this as a triangle, okay, so the difference in my x coordinates, I'm going from x is 3 to x is 5. So actually it's going along 2. And I'm going from 7 down to 5.5. So it's going down 1.5. Okay, now that's 5 parts of my ratio. So this triangle here is going to be 2 parts of the ratio. So if we think about what's happened, so this is 5 parts to 2 parts, you're actually dividing by 2.5. So think of it like similar triangles. So if we think about that first triangle, it's bigger. It's 2.5 times bigger than the small triangle that I've just drawn. Okay, so therefore each side is going to be 2.5 times bigger. So this side here, not very nice numbers. So your scale factor is 2.5. So to get your difference in your y coordinates, we're going to have to do 1.5 divided by 2.5. So you might want to work in fractions, maybe slightly easier. So change it to a fraction by multiplying by 10 to make it simpler, and then divide by 5. So 3/5, or if you do prefer working in decimals, 0.6. So this side of the triangle is going to be 0.6. Okay, and if we do the same thing with the difference in the x coordinates, so we had 2, so we now got to divide that by the scale factor, which is 2.5. So if we double this fraction, we've got 4/5, or 0.8. Okay, so we can then use that to work out the coordinates of C. So I'm at x equals 5. I've got to go along 0.8. So I'm going up to 5.8. And for my y coordinate, I'm at 5.5. I'm going down 0.6. So I'm ending up at 4.9. So it's all about similar triangles. Okay, so nice clear diagram. If they don't give you a diagram, draw your own diagram. Number 5. So we want to work out what dy dx is. So I've got to rewrite this equation so that I can differentiate it. So 2x to the 10 is okay, but I just want to change the power. So if it's x divided by 2, it's the reciprocal of x squared. That becomes x to the minus 2. So remember, negative powers cause a reciprocal. So I can now just differentiate by moving the power to the front. So 2 times 10 is 20. And then taking 1 off the power, so to the power of 9. The next one, minus 3 times minus 2 is 6. Take 1 off the power is minus 3. Okay, and there's no expectation for you to put that back. So obviously that means 6 over x to the power of 3. But you don't have to do that. It's unnecessary working. So it's just 20x to the 9 plus 6x to the minus 3. So have a go at number 6. So number 6 is an algebraic fraction, something you could see in a GCSE paper. So we're going to factorise. So on the top, I can take out 5. So look separately at the numbers, then the x's, and then the y's. So if I look at my numbers, I can take out 5. In my powers of x, I've got an x and an x squared, so I can take out an x. And I've got a y and a y squared, so I can take out a y. So that leaves me with 5 times 3 for 15, x times x for x squared, and I've already got the y. And then for the next one, I've already got the 5, I've already got the x, so I just need to multiply by y to get y squared. If we do the same for the denominator, so if I look at my numbers, I can take out a 4, and there's nothing else I can take out that's in both terms. So it's going to give me 3x minus 1y. And I've then got a factor of 3x minus y on the numerator and the denominator. So they can both be cancelled out. And I've got 5xy over 4. For number 7, trying to work out the area of this rhombus. So we've got a side length of 8. Remember the properties of a rhombus, so it's parallelogram where all the sides are the same, so that means they're all 8. We've got an angle of 60 degrees. And we're trying to find the area. So we probably want to cut it into 2 triangles. So remember all the sides were 8. Okay, and obviously that is a line of symmetry. So you can just work out the area of a triangle and then double it. So the area of a triangle, remember, is half AB sine C, where A and B are the sides either side of the angle and C is the angle. So you want both sides and the included angle. Okay, so we're going to do half. So the area is, remember, just this triangle here. 8, 8 sine 60. So half times 8 times 8 is 32. And then sine 60 is one of the angles that you should know. If you don't know it, you can draw a triangle. So equilateral triangle. So all the sides are 2. I'm going to cut it in half to make this side 1. And because it's an equilateral triangle, it's going to have an angle of 60 degrees. Okay, and then this remaining side, so the height is going to be 2 squared, take away 1 square rooted, so the square root of 3. So if I want sine 60, I want the opposite side over the hypotenuse. So sine 60 is root 3 over 2. So 16 lots of root 3. So therefore, the whole area of the rhombus is 2 lots of that. So 32 root 3. So that could be a question that you had at GCSE as well. It's quite straightforward. So next one gives us a curve, gives us the maximum point, the minimum point. It intersects the y-axis at n, and the curve crosses the x-axis at 3 distinct points. So it's asking you to use that information to sketch the graph. Okay, so if we think about roughly where it is in the sketch, so minus 113 is point L. So minus 113 is going to be, let's say it's here. So your maximum point is at L. So we know it's going to do that sort of shape. The minimum point is at 2 minus 14. So it's going to be 2 minus 14 somewhere down here. So this curve, it's going to go all the way down here. So M is 2 minus 14. So when minus 1 looks a little bit like a 7. There we go. Okay, intersects the y-axis at n. So this point here is n. And the curve crosses at 3 distinct points. It's got to cross 3 times. If we extend this down here, we've got 1, 2, and it's got to come back up again for 3. Okay, and then we've got all the information, L, M, and N on our diagram. Okay, so circle theorems, they're giving us a lot of information in this question, but it is all on the diagram. And we want to prove that A to C is a diameter. Okay, so if we're trying to show that A to C is a diameter, we might want to think about the other angle in the triangle. So if we think about this angle here, so it's ABC is 180, and I'm going to subtract the other two angles. So subtract 4x and subtract x, 180, take away 5x. So I don't know how I'm going to use that at the moment, but it's probably going to come in handy. I'm going to do the same for the other triangle down here. So this time I've got a 3x and a 2x. So ADC is 180 minus 3x minus 2x. So also 180 minus 5x. Okay. So these two angles are in a cyclic quadrilateral. So therefore, they're going to have to add up to 180 degrees. So I know that my 180 minus 5x and my 180 minus 5x has got to add up to 180. So I'm adding two things together that are 180. So I'm just going to write that as two lots of 180 minus 5x. Okay, so therefore each one of them has got to be 90. So if we look back at the diagram, because I know those two angles are 90, if we think about the fact that angles in a semicircle has to be 90, so therefore this has got to be a semicircle and AC has got to be the diameter. Okay, so I'm going to put some reasoning here, not entirely necessary, but just so it's better to put too many reasons than not enough. Okay, so this one was angles in a cyclic quadrilateral. So what we can say is, as doesn't matter which angle you pick, I'm going to go ABC, is 90 degrees. It must be a semicircle. So therefore, AC is the diameter. Okay, so use a couple of circle theorems there. But if you're trying to show something's diameter, it's usually going to be angles in a semicircle. Let's have a look at number 10. So it's given us an expression for fx and gx, and it tells us that f of a third and g of a third are the same. So let's have a go at working them both out. So f of a third is 9 times a third divided by 2 to the power of minus 1. So 9 times a third is obviously 3. So we're doing 3 over 2 to the minus 1. And remember, negative 1 will make that the reciprocal. So 2 sorry, pen not working. Let's try again. 2/3. Okay, so therefore, if we do g of a third, we've got 1 minus, if I cube a third, I'm just cubing the top and cubing the bottom. So it'd be 1 over 3 cubed, which is 27. So it's going to be p over 27 square rooted. Okay, and I know the answer to that is the same as my f of a third, which is 2/3. So if we solve this equation, I can square both sides. And then rearrange. I'm going to put P over 27 on this side, 4/9 on this side. So 1 take away 4/9 is 5/9. So P is going to be 27 times 5/9, which is 15. Okay, we've now got a circle touches the y-axis, sorry, at 0, 2. The line y equals k intersects at 1k and 5k. And we're trying to work out what the circle equation is. So remember, for the circle equation, we need to have a radius and we need to have the centre of the circle. So we've got to use the information in the question to work out what the centre is and to work out what the radius is. So we have got not too much information here. So I'm just going to draw some lines on here. Okay, we know whatever this point is, it's going to be the same distance from 1k and from 5k and from 0 to. So all these are going to be the same. Okay, so I can see that 0, 2 is going to be on the same level as my centre. Okay, so I don't know what the x coordinate is, but I do know that the y coordinate is 2. So it's going to be x to 2. Okay, so what I'm going to do is I'm going to work out the distance between these coordinates. So 0 is my x-axis, sorry, 0 is on my x coordinate and x is my x coordinate. So actually, the length of that is going to be whatever the radius is. So therefore, if we think about doing it between 1k and x to 2, got a lot of unknowns here. So if we do the difference, so remember you make it into a triangle and do Pythagoras. So we're looking at the difference in our x coordinates as x minus 1. So square that and then look at the difference in my y coordinates. So 2 minus k squared. Okay, so that's going to give me my radius squared. So in other words, it's going to be x squared. Because remember, these are all the radius, so they're all going to be x. So x squared minus 2x plus 1 plus 4 minus 4k plus k squared is going to equal x squared. So I'm just going to simplify that a little bit. I've got my x squared is going to cancel out. So I've got minus 2x plus 5 minus 4k plus k squared equals 0. I'm now going to do the same thing for my other point, 5k. So if we do the same thing for 5 and k, so my difference in my x coordinates, x minus 5. I've then got oh, 2 and k, so 2 minus k. That's going to equal x squared as well. So x squared minus 10x plus 25 plus 4 minus 4k plus k squared is going to equal x squared. So if I subtract x squared both times and simplify this, I've got minus 10x plus 29 minus 4k plus k squared equals 0. Okay, So it looks quite complicated, but obviously because you've got the same terms here, I'm going to call this equation 1 and this equation 2. I can actually just subtract both of those. So if I do equation 1, take away equation 2, minus 2x minus 10x gives me 8x. I've got 5 minus 29, so I've got minus 24. All the other terms are going to cancel out, so minus 4k minus 4k, k squared minus k squared, 0 minus 0. So I've actually got 8x equals 24, and my x coordinate is 3. Okay, so I've now got my centre, so I know my centre is 3, 2. Obviously, I need to know what the x coordinate is, but I can see when it went from 0 to x, so my radius would be 3. So therefore, I've got x minus 3 squared, y minus 2 squared equals the radius squared, which is 9. That's quite a hard question. Okay, this one we have got, what have we got? Cosine rule, obviously they're giving you a value of cos x so that you don't have to use your calculator. So remember, this is little a, this is little b, this is little c, and the cosine rule is a squared equals b squared add c squared minus 2bc cos a. Okay, so b is 7, so 7 squared is 49, c is 4, so c squared is 16, 2 times 7 times 4. Okay, and then cos a is cos x is minus 2/7. So 49 adds 16 is 65. Then we've got 2 times 7 times 4, so that's 56. Times minus 2/7. So if we cancel the 56 and the 7, we've got minus 8 times minus 2. So 65 add 16. So 81. Okay, so that makes a, which is, remember that was a squared, 9 centimetres. Number 13, so we're trying to make W the subject. So if you bring the denominator, we do not want to have fractions, bring the denominator up to the other side. And multiply the brackets. Okay, you then want to collect anything you're trying to make the subject onto one side. So I'm going to bring 3w cubed onto this side and add 2t to the other side. Okay, and then you can factorise out w cubed. So remember, when the subject appears twice, collect on one side and factorise. So we've got 2t plus a over t minus cubed. Do the next step, t minus 3. And then obviously, because it's cubed, we want to cube root it. So your answer is the cube root of that expression. So this is very similar to what you could have at GCSE. So we're rationalising. Okay, so when you're rationalising, you want to multiply by the denominator, but you need to change the sign in the middle. So root 3, take away 1. That means when you multiply it out, your thirds are going to disappear. So if we multiply at the top using FOIL, so root 3 times root 3 is 3. Outsides, minus 1 times root 3 is minus root 3. Insides, minus 7 times root 3 is minus 7 root 3. And minus 7 times minus 1 is plus 7. If we do the same thing on the bottom, so root 3 times root 3 is 3. And then you can see that these ones cancel out. So you've got plus root 3 minus root 3, your inside and your outside, which is why we change the sign in the middle. And then you've got the last, which is -1. Okay, so you've then got, if we collect together our numbers 3 and 7, or rational numbers, sorry, and our -√3 minus 7√3 is -8√3, divided by 2, and then actually divide it by 2. So it'll be 5 minus 4√3. Question 15. We've got a point lying on the curve and the x-coordinate is -4, and show the equation of the normal is, and it gives you the equation of the normal. It's a very standard question. Okay, so if we differentiate, remember we're trying to find the gradient function. So I'm going to do dy dx to give me the function of the gradient at any point. So bring the power to the front, take 1 off the power, and we get 2x plus 5. Remember, constant disappears, so 8 disappears. Okay, so that's the gradient at any point. I don't want the gradient at any point. I want the gradient at the point x equals -4. So if I sub in -4, I get -3. So at that point, the gradient of the curve is -3. Okay, remember the gradient of the curve is defined by the gradient of the tangent. Okay, so my gradient of my tangent is -3. But my gradient of the normal, so remember the normal is the perpendicular to the tangent, is the negative reciprocal. So it'd be 1/3. Equation of a straight line is y minus y1 equals mx minus x1. So we know the gradient is going to go in where m is. And then we just need a point on the line to go in where x1 and y1 are. So we know the x-coordinate is -4. So x minus -4. Okay, we just need a y-coordinate. Now we don't have a y-coordinate, so I need to work that out as well. So we just, up here, sub -4 into our gradient function. If we do the same thing, so we want to find y when x equals 4, -4, sorry. So -4 squared, add 5 times -4, add 8. So I've got 16, take away 20, add 8. So my y-coordinate would be 4. So that's what's going to go in as your y1. And then if you look at the form, they want the equation, they want 3y to be the subject. So if I multiply everything by 3, I'm going to get rid of my thirds. So 3y minus 12, and that whole bracket will just be on its own because it had a third in front of it and we've times by 3. So I wanted 3y the subject, so just add the 12 to the other side. And it's x plus 16, which was what the show that was. Okay, the normal also intersects the curve at B, work out the x-coordinate at B. So this is also quite a common question because if you think about a curve, remember a tangent looks like that. Okay, so it will only intersect once. But a normal, the normal is a dotted line, will obviously intersect the curve again. So quite a common question. Just think about what you normally do if two curves or two lines intersect, you would make them equal to each other. Okay, if you've got y equals. So I'm going to rearrange my normal, which was here, to y equals x plus 16 over 3. Okay, so there's my equation of my normal, and my equation of my curve, remember, was x squared plus 5x plus 8. So at the intersection point, these things are equal. So I'm going to multiply by 3. to get rid of the dividing by 3, and then subtract my x and my 16, so it's all on one side. So 3x squared plus 14x plus 8. I'm then going to factorise that. So obviously there's lots of different methods for factorisation. So it does depend on how you've been taught. Okay, for something that's a hard one, this has got a 3 at the front, so it's relatively hard to factorise. Multiply your first and your last number together. So 3 and 8 is 24. And then you want two numbers that multiply to get 24 and they add to get 14. So if we list the factors of 24, we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I'm after the one that makes 14. Okay, so I'm going to pick 2 and 12. Okay, so I'm going to split 14x, so it's 2x and 12x. This allows you to split it down the middle and then factorise each half. So I'm taking an x out of those first two terms to give me 3x plus 2. And then I'm going to take a 4 out of these last two terms. That leaves me with 3x plus 2. So if I take the 3x plus 2 out as a factor, I've got 3x plus 2, x plus 4. Okay, now this bracket gives us x equals minus 4. We knew that was obviously an intersection point because that's where the normal happened. So that's not the point we're interested in. That is this point here that we already knew about. So it's the 3x plus 2 bracket that I'm interested in. So if that equals 0, x equals minus 2/3. Okay, and look carefully at the question. So this question actually only asks for the x coordinate of b. B's over here. Sometimes it might say the whole coordinates, so you'd have to sub back in and find y as well. So for this one, I don't need to do that. Number 16. The coefficient of x to the power 4 in the expansion of 2x plus a to the power 6 is 60. So this is quite a typical binomial expansion question. Okay, and I've got something to the power of 6. Okay, so if I draw out Pascal's triangle, okay, I'm basically going to keep going until my second number is 6. 10, 10, 5, 1. Remember, you add the previous two terms, so 1 and 5 makes 6, 5 and 10 makes 15. Okay, so this is the row I'm interested in for a power of 6. I am only going up to x to the power 4 though, so I won't need all of them. So if I expand 2x plus a to the power of 6, I'm looking for the term that gives me x to the power 4. So I'm starting off with 2x to the power of 6, and then my powers are going to reduce each time by 1. So my next term will have 2x to the power of 5, and so on. Okay, so as I didn't leave much room there. Hang on. So as those powers are decreasing, my powers of a are increasing. Okay, so this is like a to 0, which is 1. So there isn't 1 there. So this would be a 1a. Okay, my x's are going down and my a's are going up. And my coefficients, so this is obviously 1. This one is 6. My next one is 15. Didn't leave much room for that. Okay, I'm not going to go any further because I'm looking for x to the power 4. So I know I'm going to have that in this third term. Okay, so actually I'm not really interested in the first two terms either. I'm just interested in 15 and then 2x to the power 4 multiplied by a squared. So 15 multiplied by 2x to the power 4 multiplied by a squared is going to give me 60x to the power 4. Okay, make sure you've got brackets around your 2x because that means we're doing 2 to the power 4 which is 16. Okay, so we don't actually need the x to the power 4. We're just interested in the coefficient in front. So 15 times 16, not very nice numbers, a squared has got to equal 60. Okay, so rather than doing long multiplication, I'm going to keep these separate. So I'm going to keep that as 16a squared divided by 15 first. So 15 goes into 60 4 times. So 16a squared has got to equal 4. A squared, I'm going to divide again by 16. So it gives me 4 over 16, which is a quarter. Okay, and then a, if I square root that, is a half. Okay, now because I've square rooted, it's plus minus a half, so my two values are half and minus half. Okay, so just read the question carefully to make sure there's no conditions on A. It does say possible values, so you know you've got more than one. Okay, 3 simultaneous equations. Remember, the idea of this is that you want to eliminate one of the letters. So I'm saying equation 2 and 3, if I add them together, I'm going to eliminate my 3 B's. So that gives me 10A and then minus a C equals minus 9. I'm then going to pick another 2 equations and eliminate B. So I'm going to multiply the first one by 3. So 6A add 3B minus 3C is 24. Okay, I'm then going to pick, it doesn't matter which one, so I'm going to go with equation 3. So 6A plus 3B plus C equals 0. Okay, and if I subtract those from each other, I'm actually going to eliminate A and B. Okay, so 6A take away 6A is gone, 3B take away 3B is gone, minus 3C minus C is minus 4C, and 24 take away 0 is 24. So I've got C as negative 6. I can then sub that into the first equation that I had up here. So I worked out 10A minus C is minus 9. So 10A minus 6 is minus 9. So if I subtract 6 and divide by 10, I've got minus 1.5. I can then use those two values in any equation to work out what B is. So I'm going to go for the top one. So 2A plus B minus C gives me 8. So A is minus 1.5, so that would be minus 3. Add B minus 6 is going to give me 8. So B is 8, and I've got 3 on this side, so take away 3 is 5. Okay, so you want to eliminate one of the letters, then pick another 2 equations, eliminate that same letter, and use those 2 simultaneous equations. Number 18. Okay, you just got to think about what you know about powers. So to the power of negative 2/3, the third is a cube root. So the cube root in x, and we're doing it to the power of minus 2. Okay, so we might want to do reciprocal and then cube root of x squared. Okay, now 12 1/4 is a bit awkward, so I'm going to put that as a top heavy fraction. So 12 times 4 gives me 48, so that'll be 49 over 4. What this allows me to do is flip my fraction upside down. So if you've got a fraction on both sides and you're rearranging, you can literally do the reciprocal of both, and you know that they're equal. So I've got squared and a cube root to sort out. So I'm going to actually sort out the squared first, and the inverse operation is obviously square root. So if I square root 4, square root 49, I get 2/7. Okay, I've then got cube root. So that means if I want to get back to x, my inverse operation is cubing. So I want to cube 8 and cube 7. So 7 cubed, not a very nice number to do. So 7 times 7 is 49. So you're doing 49 times 7. So 28, 34. Okay. Quite a lot of differentiation in this paper. So we're trying to show it's an increasing function for all gradient, for all values of x. So that means the gradient will always be positive. So if I differentiate this function, hopefully you've got the idea by now, bring the power to the front, take 1 off the power, take the power to the front, take 1 off the power, 25x is going to be 25. Okay, so that's my gradient function. Now, if that is an increasing function, then that expression is always positive. So we need to now show that that expression is always positive. So I'm going to factorise out the 6 to get x squared minus 4x. I'm just going to leave the 25, so you don't have to include that in the factorisation. Okay, and the reason I've done that is because if you complete the square, that will show you that it's always positive. Okay, so x minus 2 squared minus 4. I'm then going to multiply my 6 back through, so 6 times the brackets and 6 times the minus 4. So my expression has changed into this form, +1, sorry. Okay, so think about what that means. We're trying to show this is always positive. X minus 2 squared is a square number. So you can't get a negative square number. Square number will always be positive. You're then multiplying a positive number by 6 and adding 1. So that is always going to be positive. So x minus 2 squared is a square number. So therefore 6x minus 2 squared plus 1 is always bigger than 0 for all values of x. Therefore, as the derivative is always bigger than 0, it is an increasing function. So think what that means. It means the gradient is always positive. Number 20, we've got an identity. So we're showing that 2 cos squared is identical to 2 minus 2 sine squared. So it doesn't matter what side you start with. I'm going to start with the left-hand side because I know I can replace. If I'm trying to turn cos squared into sine squared, I know that sine squared add cos squared is 1. So if you rearrange that, I can replace cos squared with 1 minus sine squared. Okay, I can then expand those brackets, and that was a nice, easy identity for me. Hence, it's only worth 1 mark. Okay, when it says hence, it normally means use the previous part of the question. So because you've said hence, we have to use that part up here. So this 2 cos squared, I'm going to replace with 2 minus 2 sine squared theta. Okay, and then I've got a quadratic, so I'm going to put everything on one side. So my 2 sine squared is going to go over to the other side. My 3 sine theta is going to go over to the other side. And my 2 is going to go to the other side to make +1. Okay, you've then got quadratic, so you might prefer it if you write it as 2s squared minus 3s plus 1. So we're factorising that. Okay, so it doesn't matter what your factorising method is. This one's quite easy to factorise because it's going to have 1 and 1 on the end. We're trying to make minus 3s. It's going to be minus 2s and minus 1s. So your sign is going to have to be a half or 1. Okay, so you've got to solve from 0 to 180. Sine theta equals a half. Okay, so you should know the values by now. You've got the triangle above if you want to go and check. That gives you an angle of 30. Okay, to get the next one here, you're going to do 180 take away 30 to get 150. So there are your two answers. Sine theta equals a half. For this side, you've got sine theta equals 1. Might be easier to use the graph rather than the cast diagram. So we're just looking for this value where sine theta equals 1, which is 90 degrees. Okay, so for 90 degrees is your answer. So we've got 30, 90 degrees, and 150 degrees. So they are your answers. Okay, and that is the last